So let me just dive right in. As always with me, I strongly encourage you to ask questions, just interrupt me. Oh, I'm not presenting, am I? Let's fix that. Um, there, a window. Here we go. This
Can you guys
is,
hear me?
yes, we can hear you.
Oh, that's insane. That's awesome. Woohoo. Audio's working. All right.
Fantastic. So I hope this is showing my PowerPoint. Sweet. Okay. So this is meant to be a bit of a continuation of last time for reasons we'll hopefully get into depth into. So really quick again, hi, I'm Leo. I work as a data scientist at Avanade, where I, do everything data science. I live in San Francisco with my wife, and I'm a former SharpestMinds mentee, and I'm mentor in SharpestMinds. And as always with me, just interrupt me, make corrections, have suggestions, ask questions, whatever you feel like doing. I'm trying to provide you as much value as I can. My main reason of doing this is I want to help people. And so let me help you the most efficient way. So if you have a question, just feel free to write in the chat or just tell me. Or if you have a favor, just like, hey, could you go into a bit more depth? If I can, I will. If I can't, I'll tell you. So, okay, cool. Let's just get started. Last time, I want to have this a quick recap because I think there's a good reason why. We spoke a bit about the strategy of picking a project and sticking with it. And yes, Jeremy, the title you suggested was much better than the title I originally gave it, so let's stick with that. And then also one of the points I kind of highlighted was, and I wish this wasn't as rushed now, is that part of your skills as a data scientist are qualitative as well as just quantitative. As in, you're not, sometimes you are, but you're not just a statistician, right? You just don't focus on the stats. You focus a lot of the business, you focus a lot of the end user, you focus a lot of what other additional insights can we gain other than just crunching some numbers. The crunching number part is huge, obviously, right? That's why we probably started in this field, but it's not everything. And I wanted to connect the dots here a bit between what I spoke to last time, the strategy and how you can interact with different teams, and to the unsupervised learning part, as into why is that suddenly an inherently qualitative task as well sometimes, right? Cool. So I'm not going to go through all of this as much recap as I wanted to. I'm going to dive right into, okay, now for something completely different. If you don't get the reference, means I'm just getting too old. Clustering, right. Let's really quickly dive into clustering a tiny bit, because that's the first thing we think about when we speak about unsupervised learning, right? Cool. So for clustering, there's different approaches to clustering, different things clustering can optimize. We'll get into a bit more detail into that, and then try to connect the dots between what I said earlier and where we're going with this. But really what clustering is, you're trying to find subpopulations of a population, right? These are your users, this is your population of users, but you also know, hey, there's different personas in my end user. This is an example. It could be very different thing. It could be bees, and you try to find subspecies of bees. It could be you try to compress information, and it could be part of extracting features. We get into a bit more detail about all that, but basically what you're doing is you let the computer with some fancy math and stats come up with the patterns that naturally emerge if you shake the box enough, right? Cool. That's clustering in a nutshell. And clustering is based on different things. It isn't always just distance and density. There's a lot of tinkering that goes into that. Hopefully we can get into a bit more depth into that too. I'm, again, apologizing that everything's a little rushed today. Cool. Here's a quick overview, something I just grabbed from the scikit-learn documentation. I really like it. It's the same exact data, and you throw different clustering algorithms at it, always with the same metrics in this case. Well, not always actually, but then you can always pick different metrics as well, and that will spit out very different things. Hopefully we can get into a bit more depth that later too. If not, we'll have another session about this, because that's one thing that I really want people to be able to brush up a bit. And again, I'll try to give you some pointers on all the stuff that's out there, and then it's also up to you to do the extra bit of research and ask me questions. And yeah, however I can provide the most value, as I said earlier. So real quick, right, you all know k-means. K-means is super useful, super quick, essential, so that I assume you've all watched or attended past office hours. I'm not going to go into a whole bunch of detail into that. If there's some algorithms that are completely unknown to you, just mention them, and we will brush them up on them a tiny bit. I think that's a really cool exercise to do. But k-means is often our go-to reference. And I want to kind of highlight some of the things where it doesn't work as well, where you want to inherently pick another algorithm, where you want to think about the distance metric that you're choosing, and where it really all depends on a whole bunch of things. And now let's dive into that, right? So first of all, what's your goal for the clustering? That is crucially important. As you remember my ML strategy part, if you have one goal and then you pivot, it can change everything. So first thing you should do is, again, and I'm sorry if that's a little repetitive from last time, find out what's your goal, find out that's signed off, find out that everyone's aligned on, everyone has the same vision as in, okay, we're doing marketing analysis, we care about the personas, we care about the insights, we not care about as much predicting as in who will be what kind of persona, but we care about the insights that we get, right? So I already touched on the first kind of subtopic here, is it intrinsic versus extrinsic? As in, what are your goals? So you just try to learn from the data, or you try to like create features to then use for subsequent tasks? Those are then very different. You'll probably have different approaches. And the thing that I'm trying to highlight here and try to connect to the earlier presentation, to the earlier office hours, is that the learning from your data is often a very qualitative task. And this might sound very uncomfortable to many data scientists and statisticians out there, because that doesn't resonate to many of us as much as it would be as I've told you, okay, here are the 3 metrics that you can always use that will always spit out the ground truth. It doesn't, unfortunately, work like that a whole lot. Maybe, though, it's fortunately, too, because you can use some of the insights, some of the intuition that you gather and add the extra value. That's something the company is looking for, too. Your employer, or whatever is it, the situation you'll be in, often cares about the bottom line, right? Most times you won't be in an academic task where you just care about improving one thing or the other. Oftentimes after SharpestMinds, you find yourself, okay, I'll join this company. We care about maximizing revenue. We care about attrition rates, these sort of things. So often then when you learn from the data, it isn't just, oh, here's one metric that we now improve over the other metric and so on. Often it's also about, okay, but what does the data tell us? What do these clusters tell us, right? And there's an inherently quantitative thing about it that you have to be okay with when doing this. In fact, you have to embrace it and try to maximize the value that you gain out of it. For example, one of the projects I finished this summer was that I did, I'm a contractor, not contractor, sorry, I'm a consultant. Sorry. So I was consulting a medium-sized brewing company, and one of the tasks that I did for them was I did a segment analysis of their shops, of their distribution centers, and that kind of stuff. So I used clustering for that. And then what I was trying to get to was that, hey, what additional value can I provide as a data scientist with these clusters to you? What don't you already know? How can I help you increase the bottom line with some qualitative analysis of the quantitative task that I just did, right? So, and I can't go into all the details, but there were some interesting things, such as that, hey, we found really interesting correlation. But that happens of you going through the summary stats, of you doing some visualizations, of you doing some additional analysis on the clusters that you've created. You have to argue, and often you have to first convince yourself, do these clusters make sense, right? And often this isn't about metrics. Often this is about, do these fall into the right places? Do these clustering of shops make sense? Does it make sense that these shops, even though they're in completely different sides of the country, are in the same cluster? What do they have in common, right? And then you see, okay, these clusters make sense because here's all the small-sized shops that tailor to a more urban crowd. Here's all the huge retail stores that tailor to whoever, and so on, right? You go through analysis and you see if the clusters make sense. If they don't make sense, you shake the box again. Maybe you apply a different algorithm. Maybe you use a different distance metric. Maybe use a completely different approach. And I hope we get into some of the intuition behind that too. It's a little rush today, but we'll get there. And if this isn't enough, I have no problem coming back to this topic again. I apologize, we started a little late. Cool. So as I said, the different aims, you have different aims to different tasks, right? So for example, when you do a cluster analysis cluster analysis in marketing segmentation, you try to cluster groups in marketing analysis. One thing you really, I think, I'm trying to help you with some of the intuition here. I think intuitively what you care about is, are there any big gaps between my clusters? Because if they are, there aren't really groups then. Maybe I should increase the number of clusters. Again, this is a lot of qualitative analysis that goes in here. You look at it, you visualize it, you look at the metrics and be like, okay, clearly I need more clusters. Sometimes there's some ways, and we get to the metrics later on, where there's cues in the metrics that will tell you you should probably increase the number of clusters, et cetera, and so on. But the bottom line, it's still down to you making the last call, if you're the data scientist in charge, as in, do the number of clusters make sense? Does it make sense that I use k-means here? Do the assumptions, did I clarify my assumptions? And here's what I tied back to the other office hours a couple of weeks ago, is that your assumptions are crucially important, and your assumptions change your approach dramatically. Right. For example, if you can't have the assumption that, oh, well, it's the density doesn't really matter, so I can use a k-means more than other, then you should probably pick a different algorithm then, right? Maybe you should use a density-based scanning with the application of noise, DB scan, or something else. If you say, oh, really, there should not be any unassigned points, as in every point should be assigned, that is the assumption I have to make, and it's been signed off, and you can't use DB scan, right? So verify your assumptions, and of qualitative analysis that goes into this, more so than of other tasks, I'd argue, right? In the end, there's a lot of qualitative analysis anyway, but even inherently, just a clustering algorithm for the gathering of insights, there's a lot of qualitative tasks that are being asked of you. And this might not be a common thing in data science, you believe, but this is crucial here. Cool. But then for different tasks, there's completely different aims, there's completely different goals, and then you probably use a different algorithm, you use different distance metrics, you use a different approach. So for example, when you try do data compression, or you just try to reduce your number of features, then suddenly a good representation by centaurs is crucially important. That's one of the things you need to satisfy then, right? Sometimes you really care about just having a really homogeneous distributional shapes. And this might be a case when you say studying the population of different kinds of fish or something, and hey, here's some of the true labels, some of the true classes. These are different species of fish. I'm trying to find a clustering algorithm that most matches these. Then you care about what the distribution looks like, right? Most of everything, at least. Cool. Let's dive a little deeper into that. So I've already mentioned then that one thing was the homogeneity between within the clusters, right? And we get into some of the metrics a little later on. But then there's also, as I just mentioned, a homogeneity between the distributional shape, and you want that to match. And you can, if you've studied this a bit, like some econometrics and stuff, oh, well, he's referring to this in this model. We get into that in a bit more detail later, maybe. But important thing is here just the intuition first, and then you can always deep dive into models later, right? What I want you to think about is every time you look at those tasks is, what is important for me? Is it important for me that I have no separation between the different clusters? Is it important for me that the distributional shapes look good? Is it important for me that every point is assigned? And that will already give you strong cues, or already discard certain algorithms that you can't or cannot use, right? Cool. Then between cluster separation points, we get into some metrics later on, maybe. But first of all, any questions so far? Because I know I'm really rushing at this time.
I just want to jump in and say you're doing great despite the rush, and I apologize for imposing that rush on you as well. I did have a quick question about this.
Sure, please.
Do you have any thoughts about, like, under what circumstances might you care more about, for example, within cluster distributional shape,
yes, versus
within cluster homogeneity and that sort of thing?
Yeah, it's a perfect question. Yeah, let's go back to it one slide. And part of it, a huge part is it really depends on your task. Ask yourself, ask the people with the domain knowledge if you don't have that domain knowledge yet, or if there's experts that you can go and interview. It's something I wanted to highlight again from the first office hours, is that if you're not the expert in the room, make sure that you do interview the expert in the room, get that domain knowledge, and then try to make the best known decision based on that. So, for example, if you're doing some kind of, you try to cluster groups on a social network, say, right? You try to say, hey, who are the different voter types, right? It's who are the different type of users for our final end product? Who are the different people who consume our end product, right? What you really care about then, I'd say intuitively, is that you don't have big gaps within one cluster, right? So that you have one blob here and one blob over there, and actually we can look at that in a second. Because then intuitively I'd say, well, no, actually no, those are two different groups. Maybe you don't have the right number of clusters, because often that's a hyperparameter you have to pick. And then that's something you really care about. If it's a mix of if it's almost being supervised, where you have some subset of true labels, suddenly the thing you might care about the most is then the distributional shape, right? Is it shaped the right way? Because I know the two classes, right? So then you really care about picking an algorithm, maybe like it's a Gaussian mixture model or something that can do ellipsoid, and it's not like k-means kind of completely oblivious to the shape in the end, right? But you care about a certain shape then, right? So it really comes down to the task that you're doing. And this is really, really dependent on a lot of factors. Do you have some, like even if it's partially, if it's semi-supervised or something, you have some prior existing label of the ground truth of the true labels? If you do not, is there a way you can get to some of that? And then can you already see some distributions shaping up? This might require a lot of extra work and extra cost, right? There's just connecting that to the office hour a couple of weeks ago. But these are important questions to ask. So part of your journey for each of those projects is an exploration stage where you have to go do that research, and you have to be open-minded about it, because in the end you might pick an algorithm you just don't like, because let's face it, we all have our little favorite algorithm that we love and other ones that we just don't like. But sometimes we shouldn't overlook the third child, right? Or whatever that is. Sometimes the little runs can provide the best results. Part of getting that to there, though, is asking yourself some of these questions, right? As into, would it be acceptable if any data points in the end were not assigned were noise? If that's not the case, then you cannot use dbScan. It's just a fact, right? So it's part of the journey. And I'm sorry, these are like very, you might seem like, oh, where's the hard and fast answer? I don't think there is one right away. It is part of your journey. It's part of your exploration. And it's so task dependent. It's so domain dependent too, that often you look at the same algorithm, but by taking a different distance metric, or by just tweaking a tiny bit, it's completely different assumptions, completely different. It looks completely different, and you wouldn't know that ahead of time, or maybe you could find that out ahead of time by interviewing the experts. But sometimes it's exploration, it's analysis, it's iteration, right? If you think back to the slide long time ago, and the last office hours, is it's this, as in, you pick an algorithm, you pick a distance metric, you realize it's all poo, and you got to do it again. And you go back to later stage, you realize, oh, some of the data is screwed up. Oh my God, is that a problem in the pipeline? You need to go back to and so on, right? It's an iterative process, and it's up to you. And I can't give you hard and fast rules for this, because I don't think they exist. I think there's good intuition in there, as into find the experts, find out what is important, what assumptions are correct, and then with your knowledge of these algorithms, then pick one. With your knowledge of distance metrics, or the lack of a fitting distance metric, you can then create the right one. You can then apply the right one, right? And let's look at this, for example, again, right? This is something for you to study, as in, when you do clustering, you got to know what else is out there, what the pros and cons are, and then you build some intuition for it, as in, oh, does the shape matter? Does noise matter? These sort of things. Yeah, that's a very long answer to your question. I hope that was helpful. If not,
that was great.
Ask
Thanks,
a follow-up question. As you know me, always happy to dig a little deeper. Cool. Let's dig a little deeper into. Yeah, we've kind of sped through this a tiny bit, but so think about what kind of metrics would naturally apply then, and we go through some of the metrics and maybe a later iteration of this talk, or maybe I squeeze it in the very beginning of the next office hour, something like that. But right, just intuitively, right? What can you compare, right? You can compare how far, and this is probably going to ring a bell for a lot of you people, is how far is the distance, the average distance from all the data points of one cluster to the next nearest cluster, right? And the average of the one you pick the nearest cluster, and that's a silhouette score, right? So you already know that's out there. But then you can do variances of that, and you can use the variance. That pun wasn't intended. You can use compare the variance. Hey, how does the variance shift, right? Obviously, you got to know the edge cases. Say like, hey, if you have a data point, I have a cluster for every data point. Yeah, we minimize the variance, but does that make sense, right? But you can use the different metrics to even give you different insights here and the different directions in which you can go, right? Cool. Another thing I want to mention is I've mentioned the between cluster separation. It's important too. Sometimes you really want to have a real clean separation. Other times you care less about that. You care more about other things. Another point is stability. One thing you can do is you can try to make it, and I think this is probably going to scratch an itch for a lot of people who are already cringing when I said qualitative so many times, is, hey, create your own test set. See if the clusters fall into the same pattern. If you have, very beginning, you do create the basics for k-fault validation, and you see if the same clusters would shape up with slight iterations of the data, right? That makes sense. So you could you could train a first set of, you could look at the first result of clusters and then see how does it change from iteration to iteration. How stable is it? That's what I mean by stability here. Kind of scratches the itch of having something quantitative to point to, doesn't it? Loss of information, like PCA, right? Spectral analysis, clustering, spectral clustering is all built on that. That's something that's important to keep in mind, right? I see questions popping up. Should I answer them now? I'm sorry, they flashed by so quickly. I'll look at them real quick.
They're
yeah,
open
go ahead.
in the chat. Do you want me to read them out loud just so everybody can hear them?
Yes, please, if you wouldn't mind.
Yeah, absolutely. So it's coming from Scott. So he's asking, what experience do you have with using weights in clustering, either weighing each observation differently or weighing the distance measured differently based on the closeness to certain characteristics, columns versus other characteristics? And also he's asking about TSNE and if you can recommend any related or better techniques.
I might have to ask a follow-up on the TSNE one. But first of all, weighting is a phenomenal approach to dealing with imbalanced data sets. So when you look at clustering and one of these clusters is heavily underrepresented, if you weigh it higher, either by oversampling or by weighing the distance, multiplying the distance metric by a certain weight, these sort of things, there's different options of how to go about this. It's a phenomenal approach to dealing with imbalanced data sets. That's my first intuition and my only experience with using weights. There's probably other ones where, you want to now think about density more, so maybe you throw in a weight then, but I'm not less sure about that. But generally, imbalanced data sets is where what comes to my mind when I think about, why would I apply weights? And vice versa, if I look at imbalanced data sets, I'm like, maybe I should apply weights here for certain clusters or the like. Cool. And for experience of TSNE, is and I do believe it's an agglomerative approach, where you just try to visualize in the end what's the closest to each other. The only experience that I have of it is for brief data analysis, and I try to visualize something because usually you have so many dimensions that visualization is really hard. And the important thing to know is that it's a very unstable method, as in it's absolutely non-determined. You change a tiny bit, and it will, since it's agglomerative, it will shake out completely different results. So, one potential problem with TSNE is it's very unstable, right? And then other approaches that come to my mind at least would just be PCA a million times until you have something that you can look at. Then again, this might be good first draft for something, but you can only rely on visualization for so many dimensions so much. I hope that helps.
Just to kind of park the thought, we do talk about dimensionality reduction, PCA, TSNE in another office hour.
Perfect.
So, Scott, that might be of interest if you want to check that out later for what it's worth.
Cool. Yeah, so TSNE is a useful visualization tool, potentially. Just bear in mind that it's inherently unstable as into any agglomerative method is, right?
If I can just sneak in a quick thought as well, one of the biggest distinctions between PCA and TSNE is sensitivity to nonlinearities in the data as well.
Oh yeah.
So PCA only looks at linear correlations, whereas TSNE is
Excellent. Thank you. Cool. All right. Let's move a little further. Let's see what else we can get done today. Cool. So I kind of touched on this very quickly, and then how do you evaluate it? Is there some kind of benchmarking approaches that you could use? You had a real-world data sets with known classes, and then you can just use misclassification labels on them. Fantastic. A couple of issues with that we deep dive into it. Not deep dive, but we'll highlight in a minute. Then you could use simulated data sets, and you can create them like Gaussian mixture, these sort of things. There's issues with that too, as into the actual distributions might not show up as cleanly as you'd expect. And then is that really a good way to evaluate if it's all now one big blur? Yeah, what are the clusters, right? Is it the underlying ground truth function that you've applied, but you just don't see in the data anymore? Or is it the clusters that now shake out naturally when you apply the algorithm, right? And then, of course, there's real data sets without known classes. And that's usually what we do anyway, because usually when we do clustering, we don't know the ground truth. We don't know, hey, it's cluster 1 and 6. And by the way, those clusters are arbitrary, right? Next time it could be 6 and 1 could be inversed, but it's just similar clusters. So yeah, let's go into why label data sets and the benchmarking, if that's sometimes not as advantageous as your intuition might tell you. First of all, the clustering then is not that interesting, as in, the ground truth. It's kind of like, what you're aiming for is clustering even the thing you're supposed to do in this case, right? Why not go for another algorithm that just does the job a little more intuitively? And then you'd also kind of, another inherent issue, in my opinion, is that just because there's some certain ground truth labels doesn't mean that there are other legitimate ground truth labels. What I mean by that is, listen, if you look at, for example, you found new species of insects in the Amazon rainforest, and you try to cluster them and come up with species, and you know a few of these species, you can't really extrapolate what are the next other species, how many other species should there be. Sometimes it goes even further as into, well, now that you've seen a clustering data, the thing that appears to be one species really should be two species because they're so different and so many other things that a clustering algorithm picked up. But the hobby biologists that went to the rainforest and explored didn't really know at the time. So now we know that maybe there's better truth out there than the one we currently know. So maybe the labels are even misleading. And sometimes it's, yeah. So in total, using benchmarked ground truth, known labels, data sets can be the perfect approach, or can be completely the wrong one, right? Again, it depends on your task. It depends on your assumptions. That's the kind of stuff you need to clarify. Sometimes it's the best approach. Sometimes it's the worst approach. It's really up to you in a way. Okay, so now we've come to a lot of different questions, right? We've touched a lot of these. I really don't think I can. We probably gotta go into the Q&A sooner because I can't go speed through all of it. But so there's all these different approaches, right? What's the intuition then between picking the right one? We've touched on some of this, but what I really want to do next time then is let's deep dive into some of these algorithms, and then let's pick out when is that a good approach, when is it not a good approach. What distance metric you think of? What's different between, hey, okay, now we've actually paid for some label data. How does this change our approach, etc., right? Sometimes you have parameters that you need to play around with the number of clusters. Sometimes you have an intuition as to how many clusters there should be. Say, maybe you try to do a clustering algorithm for, this is a bad example probably, but handwriting recognition, there should be 50-something or 60 maybe characters that there are with capital characters and so on. Maybe this would be the number of clusters. Intuitively, you know that. Often you don't. And finding out the number of clusters is crucial, right? As in finding out how many different there are can be an insight in of itself to your employer or your client or whoever it is, right? Cool. Right distance metric, we'll deep dive into that. And then how do you know how good your clusters are? How do you do the actual evaluation, right? Yes. Okay, let's go a little further. So sometimes, if you remember it from the office hours last time, sometimes it pays off quite nicely to invest a bit more. And sometimes that investment is, hey, you get help, or you spend some time yourself, or you get a team of people to help you annotate. Sometimes you have to have the main expert. That makes it hard. Sometimes it's trivial work. You can outsource it for no money at all. Sometimes it really pays off. And then that can change your approach a whole lot. Suddenly now you can use, error metrics that otherwise you wouldn't be able to use, etc. Right? Often, though, is when you don't have ground labels, it really comes down to, and I can't emphasize this enough, your domain knowledge, or the domain knowledge that you acquired, the experts that you interviewed. You will compare summary stats. You try to visualize as much as you can. You'll try to toy around with it. You'll go back to the experts and say, hey, do these clusters make sense? Right? It's an iterative approach. Often you'll be the person to make the last call, but sometimes there's people who have so much more domain knowledge that it would be not a smart move if you're like, no, it has to be 6 clusters because the elbow method told me so. And then a domain expert would be like, there's definitely not more than 5 guaranteed, right? Then you'd be like, well, maybe the elbow method is not maybe our data doesn't tell you the whole story, right? Maybe we should get more data, right? It's an iterative process. Sometimes it's really important to think about what happened to the outliers. Is it okay if there's noise, right? Is it okay if they were all assigned? Sometimes that is an issue, as in, if k-means just assigns every single point, and you're like, well, some algorithms inherently handle outliers really nicely. And then is that something maybe you should look into? Maybe you should compare, and that's something I really like, compare the results of different clustering algorithms, right? Maybe do a clustering algorithm mean shift where all you need to do is fire and watch, and sorry, that's the wrong term. You just fire and go, something like that. You just watch it do its work because there's no parameters that you really need to tune. And then it tells you something about how many clusters does mean shift tell you that it thinks there are, right? Maybe that gives you some intuition. And maybe if you see, hey, I use dbScan, and even when I use different vicinity scores, whatever, there seem to be a lot of outliers. Maybe I need to go back into actually doing a bit more data analysis. Maybe I need to handle my outliers better. Maybe there's something I'm completely missing. Maybe I need to transform the data, right? These sort of things. So it's a very iterative approach again, and you got to embrace that. As I think often with data science, it's so iterative, and often too, especially with clustering, I find it makes sense to just spend a bit more time with experimentation. Use the different algorithms, compare the results, maybe try having some holdout sets and do cross-fault validation, see how stable your results are, these sort of things. Okay. Yeah, no, let's park it here. We continue with this next time. I want to open the floor to questions. I'm sorry, I do have a hard stop. That's why all the rush and etc. So I strongly encourage you all to ask me questions, and then what was missing from this office hours, what you want me to talk to next time, any favors you have, or what's up?
I don't have it's not a question, but I guess I'm going to share my experience. It might be helpful to other people. I recently, at work, we finished like the MVP version of clustering for some of our customers. And I find that the hardest thing that I had to do was, and I was presenting to this C-level executives, so pretty far from any technical work. The hardest thing that I had to do was visualize what I'm seeing, because there was about, I don't know, 9 clusters or whatever, and they had 5 or 6 attributes. And, it was really hard to actually explain what's going on. Like in my head, it made sense, but kind of making that explaining all that in my head to other people was really hard. So one thing I did was one of the features was like a geographic location. So I took geographic location from all so I did like a 2-step approach where I first clustered by geography, and then I had it as a feature when I was doing another clustering algorithm. So I can at least catch on to the location if everything else fails, if that makes sense. So I was like, looks like in northeast, blah, 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 right? So that was sort of my safety fallback, because when it really didn't make, like, if you just look at in isolation one cluster, it doesn't make a lot of sense unless you see the big picture, because it's not always clear cut and it says, yeah, people in northeast do this, sometimes people from northeast, west, whatever, from all over the place fall into one cluster because reasons. So you have, and you can't always, the question is, oh, but why do these people come here and not here? So that answering that question, sometimes you can't even, like, I couldn't answer some of those questions. I could give my best opinion about it, but there's no, like, I can't give them a silhouette score and say that's why, because that's not why. There's an underlying reason why, but I couldn't figure out. That's why the first version, I want to figure out why that a lot of those things are happening. But I think at least we found out a certain, like, okay, customers from this area purchase this much and they use this method roughly.
Yeah.
It's not always an answer, because you can look at this other cluster where that same type of a customer but using something else, but majority of the customers are using this. So it was really fun, but the hardest part was actually explaining that. And that was my sort of 2 cents on that.
Yeah, I think you touched on excellent points there, and there's a lot of things I agree with you there. And it's funny because I had a really similar approach to when I was presenting the results of my clustering analysis to the client, the medium-sized brewery, which was to, let's throw in some maps, because it's hard to visualize a cluster to so many features that we have, and we've, on top of it, we've generated some features, we've extracted some features, we've thrown out some features.
One quick thought, just to toss this in, because I have heard this used really effectively, especially by people in analytics and visualization, is just the idea of archetypes. So if you can identify, pick out a cluster and go, oh, this is like the stereotypical person from this cluster. It'll sometimes fail, but at least it's something that a C-suite executive's brain can latch on to.
Well, that's exactly what we did. We helped the marketing team create the different personas, and then we're like, hey, this is the young urban, that has disposable income to spend on your beverages, and he goes to these type of beverages. And this is the rural traditionalist who likes the IPA. So these sort of things. And I want to touch on all the points that you mentioned. So first of all, visualization is always really hard, right? It is an inherent problem in data science, because we're looking at more dimensions that we can visualize, right? So, and the danger is then if you use something like t-SNE, it might just shake out so differently, because it's an inherently different technique than techniques that you use, that it does more harm than good than using and including that. So I think your intuition was spot on. What you did was, it's something I did myself. So throw in some maps, show, hey, how, like, the distribution of the clusters, maybe by region and so on. You can, throw in some pie charts. People have pie charts. Whatever, right? You can use other features, right? And then the other thing that Jeremy just mentioned is perfect. You talk about the clusters from a business perspective, as into, why do you care about this clusters? What does this cluster tell you? What did the numbers of clusters tell you? Hey, you have so many personas according to our analysis, right? You might want to split that up further. If that's not granular enough, maybe you want to lump these two together because they're pretty similar in some regards. But we think this is a good number of personas. Here are some of the characteristics of these personas. And this is inherently very qualitative. It's also a final product. You don't have to make predictions. This is your result. This is adding value to the bottom line. You can go to marketing team with this, and they will love it if you do it right. And they will, and you'll get a lot of credit for it, because you've now given them something tangible, and you can test them. They can run additional studies. Maybe you can really suggest some of the additional studies going on into this. Like, hey, I know we have a qualitative team that can do research some people, interview some people, see if those personas make sense after we've run, say, interviews or some other more qualitative approaches like diary studies, whatever it is. And if these corroborate our results, you're golden. Like, yes, a final product right there. You can build things on top of it, but you've achieved, you've conquered, you've done well, right? So so yes, visualization is hard. Summarizing is good. Use whatever features. Often the interaction between certain features is something you can visualize, right? And often that's super interesting, and it's an insight you get, or sometimes clustering helps with that. Sometimes it just falls off right at the beginning. Throw that in there, right? The result in the end, your product that you present doesn't have to be just the one thing that you just did and spent the most time on. It can be like, hey, by the way, doing my analysis, I found out this. Here's really cool interaction with this, and according to my statistical analysis, this is a very predictive feature for this and that, right? Wow, that's an insight right there. You can translate it into ROI. Fantastic, right? So I think intuitively you really did all the right things.
I think one thing that I did. Oh, sorry.
No, go ahead.
One thing that I learned. So I stole this from my friend he's going to USC, and he's studying this class where they're doing customer value metrics, and the guy basically who invented customer value metrics did thing, and basically they were doing clustering, and they gave names to groups. But I found out that later after I presented that I should do that, and I was like, oh man! But that's something that I definitely will do. And visualization that I used was I did use math, but then I stole this from a blog post somewhere where a guy did averages. So whatever the value of the feature is, and then the average, and then you group it by a cluster, and then you do bar charts for each cluster. I used that. That was pretty good. I think it wasn't perfect because it makes sense in my head. I don't know if it made sense in other people's heads, but I think at least somewhat connected with other people. That was the best that I could come up with, is bar charts and then average per feature per cluster. And then group them together.
We did something. Yeah, it's exactly what we did. So my team did the same thing where we described the clusters. We gave them names too. This is the young urbanite. This is so and so. And then on top of that, we gave the summary stats for each of those, right? And especially highlight the ones that stick out, right? Here, this cluster has the highest average age by a long shot. This cluster has the lowest opposable income, so on, right? These kind of things. And that kind of makes sense into the business too. They're like, oh yeah, it makes sense that we group these people together because they apparently are the lowest income cluster.
Leo, I'm especially sorry to cut you off at this point.
Yeah,
but I'm just looking at the time. I've already cost you your first 20 minutes. So.
I need to run. I have a stand-up that I need to run to. I promise to make up for the lost time in the next one. I'm not going to let this fall under the rug, but okay.
See you
guys. That's very generous of you, but this is entirely my screw up. So I appreciate you taking the bullet for me. But
if you hadn't said this, I didn't know.
Anyway,
so, you know.
Sure.
Okay, all right.
You just revealed it.